Good morning, guys. It's Navi joining the call. Can you guys hear me? Could you give me a quick yes, guys, if you can hear me fine?
Yes, sir, I can hear you.
Great. Thank you. Great. Thank you, guys. So let's get back to our journey. And today we're going to revisit correlation. Today we'll actually take a look at an example of a machine learning example / case study. And we'll try to dig deep into these things in the coming up days, guys. Okay. So until today, we've been looking at various concepts of Python. All these concepts will be put together and we'll be using as good evening again to everybody, guys. Thank you all. Okay, so let's get started, guys. I think we briefly discussed about correlation. Correlation analysis is used for investigating relationships between two quantitative variables. So let's see, come here, back here, and see where we are. Here we go. Okay, so the keywords, the main mantras, it is a relationship between two quantitative variables. Quantitative is nothing but numerical data, guys. Okay, imagine a coffee shop. Imagine a coffee shop, and in the coffee shop, when the temperature is high, let's say the sales are high. Why? When the temperature is high, it is hot and warm. Lots of guys are going out with their friends and relatives having coffee, tea, visiting the bakeries or bakery items and things like that. But when the temperature is low, it's cold, and nobody's moving out. As a result of that, the sales is decreasing. So what is the green one? That is the sales. The yellow one, that is the temperature. What's happening? As one is increasing, the other is increasing. Remember, as the temperature is increasing, the sales is increasing. So they're kind of directly proportional to each other. Is a very, very friendly term, friendly definition. What are they? They're both numerical, they are quantitative. And what is it? That is what is the relationship, whether they both of them increasing together or they are not increasing, they are going in opposite direction, is what is relationship. The goals of correlation is analyze if two measurement variables have relation. Are we able to interpret it? Are we able to explain something like that? Are they both going together, or they're not both going together? Change in one influences the change in other. So as the temperature is changing, remember the sales will change. As you change the sales, temperature will not change. Okay, sales is dependent on the temperature, but temperature is not dependent on the sales, guys. Quantify the strength of the relationship between the variables. Mathematically, we can go ahead and calculate by how many units or what is the strength, and we can mathematically explain it. That is what is strength. We'll try to understand what that means, guys. Okay, I may have given this example earlier. What's happening? Let's come here. So on x-axis we have a positive correlation between the height of a child and age. So here on the x-axis we have the age, on the y-axis we have the height. And what's happening? As the age is increasing, the height is increasing. What do we mean by that? If you take any of the variables, the greater the x-axis value, the greater the y-axis value. In other words, it's going in this direction. Okay, as the age is increasing, height is increasing, so they are kind of directly proportional. If it is going in this direction, we say they are positively correlated. As one is increasing, the other is increasing. As one is decreasing, the other is decreasing. And naturally, we can understand as the age of the child increases, their height increases. That is what is happening here, guys. So in other words, this is an example of positive correlation. As one increases, the other increases. As one decreases, the other decreases. And another one, see what we have here. A negative correlation between the temperature and the time babies take to crawl. So what we have is, on x-axis we have the temperature, and this is the time, how much time they're taking to crawl. What's happening is, it's going in this direction. In other words, this is negative correlation. As the x-axis is more, for this group of points, you can see their y-axis value is low. Okay? Let's say you take this group of points, their x-axis value is low, but their y-axis value is high. Okay, so as one is high, the other one is low. In other words, as the temperature is increasing, Temperature is increasing means when the temperature is hot and warm, what's happening? Babies are taking less time to crawl. They're taking less time to crawl. But when the temperature is low, let's choose this one. When the temperature is low, x-axis values are low, babies are taking more time to crawl. Why? Because they're completely packed and it's not easy for them to move. They're trying to stay warm and things like that, guys. So what is this? This is like negative correlation. As one is increasing, the other one is decreasing. Everybody with me, guys? Quick yes, please. Okay, so now let's go one step ahead. What is this? In the world of machine learning, data science, and AI, the positive correlation, and these are kind of the visual patterns. If the data, if both of them are increasing, that is a positive correlation. If one is increasing, the other one is decreasing, that is negative correlation. And here, neither we can say it is increasing nor we can say it is decreasing. This is called neutral correlation. This is positive, this is negative, this is neutral correlation. Here, the data is scattered, is another way to say. So let's take an example, guys. Take a look at this. Analysis of student grades in mathematics and English. Let's say, come back here. Choose this one. So imagine, use correlation to determine if the students who are good at mathematics tend to be equally good at English. Maybe imagine, we went to a school. What we are observing is, students who have getting good marks in, let's say for the sake of English, we'll go to English to mathematics rather than mathematics to English. Students who are getting good marks in English, we're observing they also got good marks in mathematics. Then there are a group of students, let's say they got low marks in English, and let's say what happened, we're observing they're also getting low marks in mathematics. So let's say we'll say here is mathematics, oops, one more time, here is mathematics and here is English. So let's say here is English. Oops, put this here, do that. Here is English. So it looks like as one is increasing, the other one is increasing. As one is decreasing, the other one is decreasing. So what can we say? It looks like they are positively correlated. Okay, so what is it? We can say they are definitely correlated. But if you take a new student, let's take a new student. Let's say here's a student. You take them because we're observing when English is more when the students are also scoring more in mathematics. If you take the students and you try to train them well in English and you expect them to get good marks in mathematics, that may not always be true. The student may not necessarily get good marks in mathematics. It's just that it is happening in a few students, they got good marks in English. But it doesn't mean that every student who will get good marks in English will get good marks in mathematics. What is that? That is what we mean by correlation. It does not imply causation. So let's say, come here. Okay, so correlation and causation. These are the two eyes of the data scientist. Everything is about correlation and causation. We try to understand, in a business world, everybody is trying to understand what is causing their revenues to increase, what is causing their profits to increase, or what is causing it to decrease, what is causing their profits to decrease, and things like that. They want to understand the causation. Many times what we observe correlation, but it does not necessarily mean that there is a causation. So here is another example, guys. India loses a match if Sachin hits a century. Whenever Sachin hits a century, let's say, for the sake of simplicity, Sachin is hitting a century, his score is high. It so happened that whenever he was hitting a century, the overall score was low, and as a result of that, India lost the game. Okay, let's say it happened in the last 5 games. So now imagine in the 6th game, we're playing with a tough team, maybe England or Australia, and let's say somebody is observing this pattern, and now let's say they're saying, hey, whenever Sachin is hitting century, India is losing the game, so why not we make him hit a century and they will lose the game. Imagine they make that kind of a decision. Okay, so what will happen? Well, that will not be a good decision. What is that? That's what we mean by causation. Causation means a guaranteed impact. Smoking will cause lung cancer. What is that? That is a causation. In other words, if you smoke, you're going to get impacted with a lung cancer. That is an impact. So kind of causation is impact. Correlation is, it's a pattern which is existing there, but does not necessarily is guaranteeing an impact. Okay, so we say Correlation does not mean causation. What is this one? This is like a pattern, you can say, which we will observe in many things. We try to understand if there is correlation. If there is correlation, then we'll also try to understand if there is a causation in real world. We take the data, we try to come up with these things, guys. Okay. So does Sachin hitting a century causes India to lose a match? It is not always true. What is this? This is an example of correlation does not mean causation. Okay, that's a slightly deep one, but everybody with me, guys? Can you give me a quick yes, please? Okay, and let's move on to the next one. So that's where, correlation coefficient. Mathematically, what we do, correlation coefficient is measured between -1 to +1. So let's come here, put this here, choose this one. So it is measured from -1 to +1, and it is +1 means it is very strongly correlated. If it is 0, it is neutral, there is no correlation. And if it is -1, it is strongly correlated, but it is negative. If it is in negative or minus, it is negatively correlated. If it is in positive, it is positively correlated. 0 indicates that there is no correlation, it is neutral. Okay guys, mathematically this is how we measure correlation, we try to understand. So in a machine learning world, whether you're positive or negative, whether the relationship between two variables is referred as positive or negative. If you go back to the sales of a coffee shop, the relation between sales and temperature is positive. Okay, so what is that? Whether it is positive, negative or neutral is referred as the direction. We say correlation gives you direction. Everybody with me, guys? Can you give me a quick yes? Okay, and let's dig a little bit deep more into it and you'll get understanding. So now come to the causation. If we want to understand the causation, what can we do? One of the things that we could do is regression. In statistics, regression analysis. So let's say, come here, this here. Okay. So regression analysis is a statistical process for estimating the relationships, which means regression will tell you the relationship between the variables. The focus is on the relationship between dependent variable, more importantly, dependent variable and one or more independent variables. Okay, so what is dependent? Imagine this is the sales. Imagine this is the temperature. Oops, one more time. This is the temperature. Okay, so remember, sales depends on the temperature, but temperature does not depend on the sales. Okay, so what does that mean? Sales is dependent variable, and so let's say sales is dependent variable and temperature is independent. Temperature is a process of nature, mother nature, it exists by itself. It's an independent variable, guys. Okay, so in other words, regression tells you the relationship is one of things. It can also give us a statistical causation. It will give us an indication. We'll try to understand what we mean by that. It's a machine learning algorithm. By statistical process, by mean it is one of the machine learning algorithms, and we'll try to understand a little bit about that today, guys. Okay, generally during the process of machine learning or modeling, let's say we have these are the steps, and see what that means. So the first step is you prepare the data. This is where you get the data, you acquire the data, and you try to make some changes. Lot of time goes in data preparation. So in other words, imagine you want to predict if in, let's say for the sake of simplicity, tomorrow there's a game between India and maybe Australia or maybe England. And what do we want to do? We want to predict if India is going to win or not. What do? We need to first get the data. Generally, what do? You get the last 10 cricket matches. You can get the last 20 or maybe 100 cricket matches of data. And what do? Well, you're acquiring the data and then you try to make some small changes. That is called data preparation. Okay, now imagine, let's take one of them. Let's see who do we have here. Let's say here is Rajesh, India versus Australia. It looks like he's interested in India versus Australia. Now let's say for the sake of simplicity, Rajesh is looking at the data. Okay, so for the sake of simplicity, let's choose this one. Here is data, and let's say here is, oops, come here, choose this one. Here is Rajesh. Rajesh is looking at this data, And what is he doing? Well, he is observing. He's a fan of, let's say, Sachin Tendulkar. He's observing. Sachin Tendulkar seems to be playing well when the temperature is high, for sake of simplicity. In the games where the temperature is hot and warm, Sachin is scoring high, but he in the games where the temperature is slightly less hot or cold, he was not playing well. So what does he have? Well, now he's saying, he downloaded a lot of data, but he does not have temperature data. So what is he doing? He's explicitly saying, guys, we do have data, but I want a specific thing which is temperature. Okay, let's say for the sake of simplicity. So what is he doing? He's also selecting a variable, that is selecting variables. That's a quick example, guys. Okay, then you deep dive. Are there more variables like that? That is what is deep dive. He's digging more into the data, and he's trying to understand, is there more? How much Sachin may score may depend on a bowling pitch or a batting pitch and things like that. So what is he doing? He's diving deep into it. Then he's also transforming the variables. As he's getting more understanding, what he's doing is he's making some changes to the variables, which is he's adding more data, more variables. More variables is more columns. We will try to understand that. And now what does he do? Well, once he has all the data, so let's say a little bit of cleanup. He has added the temperature and things like that. So this becomes the complete data. What he's doing, he is looking at this data very seriously. That is where we are developing a model. At a logical level, what is happening is, in his brain, what he's doing is he's painting a paint by looking at this data. By looking at this data, he's painting a paint in his brain. This, select that, that's a paint in his brain. What do we do? On a daily basis, whenever we look at the world, we look at the things around the world and things like that, we are nothing but the artists of something. We're painting a paint in our brain. What is that? That is called the model. And what do we do? Now, let's say, take another guy here. Let's see, who do we have? Let's take Sri Vishnu. Vishnu is a friend, let's say, Rajesh. Is coming and asking, Rajesh, buddy, what do you think? Who's going to win tomorrow? So at a logical level, what Rajesh is doing is he's using his paint. He's painting in his brain. And what is he doing? Well, he's making a prediction. Okay, so he makes a prediction and tells his buddy Vishnu, hey, India is going to win or not, and things like that. More precisely, whatever the paint he has painted in his brain is the model at a logical level, at a neurological level. So now, let's say Rajesh is saying, hey, India is going to win. And now what Vishnu is going to do? Vishnu is going to say, buddy, I'm going to bet on this one. I'm going to bet maybe 100 rupees, $100, or maybe a lot of money. I want you to be more serious about it. So now what Rajesh is going to do is he's going to take and test it on many other cricket matches. That is where he's called validating the model. At a high level, you can kind of visualize these steps to be like this. But let's go one step deep and try to understand. In the coming up days, we'll try to understand these steps in a greater detail, guys. Okay, so this is where regression can come to our rescue. So come back here. Okay, so imagine we want to predict what score Sachin is going to score, or how much score Virat is going to score. We can use linear regression. That is numerical data. How much score somebody is going to score. But let's say we want to predict if India is going to win or not. That's a yes or no. Then in that case, we'll use what is called logistic regression. Today and tomorrow, probably we'll be focusing on linear regression. So in linear regression, we predict a variable which is numerical in data. And what does that mean? Well, we'll try to understand, guys. Okay, if you take a look at this, this is the equation that we've seen back in school, y equals to mx plus c. And here, choose this one, with this here. Here we go. So this is like y equals to mx plus c. Y, if you go back to the story of the coffee shop, y is a dependent variable. Y will be the sales, and x will be the temperature. And b1 is the coefficient, b0 is a constant. We'll try to understand what that means, guys. Okay, so this is y equals to mx plus c. What are we saying? The sales of a coffee shop is depending on the temperature, is what we are saying at a logical level. We are now translating it into a mathematical interpretation and converting it into in the form of an equation is what this is, guys. Okay, so here we're just taking temperature. Because we're only taking one variable, this is called a simple linear regression. You have only one independent variable. But let's say, take a look at this. Yeah. If we have, let's say the sales of a coffee shop is here. It depends on the temperature as one of the things we discussed. Say put this here. This is the temperature. Let's say we're also saying it also depends on if there is a game today in a stadium nearby. It also depends if it is a festival. It also depends if it's a weekend and so on. What are these? These are multiple variables. This is called multiple linear regression. What's happening? The dependent variable is dependent on multiple factors. These factors are called variables. And what is that? That is called multiple linear regression. When you try to use multiple variables, multiple factors in making a prediction or in building a model, this equation is called a model at a mathematical level, or at a logical level we call this as a model. At a mathematical level it's called the equation. And this is what we'll try to understand, guys. Okay, everybody with me, guys? Quick yes please. This is the algorithm we're about to use and we'll try to understand that, guys. So let's say go one step forward. Now take a look at this, guys. Imagine salary and experience. Imagine you took a group of employees in a company. Do you think salary will depend on the experience or experience will depend on the salary, guys? What do you think? Do they pay you the salary based on your experience, or do they decide your experience based on your salary? Salary depends on the experience. So in other words, generally we put our dependent variables on the y-axis, independent variables are on x-axis. Salary depends on experience generally is what it is, guys. Okay, so in other words, salary is a dependent variable and experience is the independent variable is what we do. Now take a look at this one. Here is, let's say we have taken a company and we have plotted we have taken the salaries and experiences of a few employees and then we have plotted it. Let's say for the sake of simplicity, here is a guy. This guy is, let's say, 1 year experience, and let's say we are paying him $30,000. Let's say this guy is 2 years experience. Okay, so this guy is 2 years experience and we are paying him, let's say this is maybe $25,000, and here is a guy with 3 years experience. We are paying him $25,000. But let's take this guy. This guy is 7 years experience and we are paying him $100,000. So in other words, what we have done is we have taken a group of employees. We have plotted the salary and experience on the on a x and y axis. Okay, now what shall we do? Now take a look at this. We'll draw a line. This is called a random line. Somehow, how we draw the line, we'll try to understand. Somehow we have drawn a line. And what is happening is, this equation of line, let's say, for the sake of discipline, will represent like this. Y equals to mx plus c. Y is going to be salary. Okay, that is a dependent variable. Experience is going to be your independent variable. We are representing it in the form of, at a mathematical level, we're representing it as y equals to mx plus c is what it is, guys. Okay, now in what way is this line useful to us is what we'll try to understand. So take a look at this one. If you notice, what's happening is the line is meeting the y-axis where x-axis is 0. Where x-axis is 0, where the line is meeting, it is indicating $30,000. So what does this mean? Based on this data, because this line is meeting the y-axis here, we will now translate this and say this line is suggesting for somebody with 0 years experience, pay them $30,000. Based on this data, we are saying that, guys. Okay, let's go one step deep. Let's say come here. Take a look at this. Here's what we have. Now, from this line, what this is saying is, imagine Rajesh is completed 3 years. Let us say this is 3 years and he's going to 4 years. So what do? We take the 3 years, you project it onto this line. You take the 4th year, project it onto this line. We're supposed to give some kind of a bonus to Rajesh. So what are we doing? You project it onto the y-axis. You project this onto the y-axis. This is indicating a difference of $10,000. What is it suggesting? It is suggesting that for somebody who's going from 3 to 4 years, you give them a raise of $10,000 is what it is suggesting. So imagine we go back. And now we are making a couple of decisions. What is it? When a fresher is going to come and join, we're going to give him $30,000 as his salary per annum. And if somebody is going from 3 to 4 years, what do? We give them a 10,000 raise. But if somebody is going from 4 to 5 years, what do? Repeat the same process, try to identify the difference. And what are we doing? We are now making business decisions. We are making business decisions based on the mathematics of the data. Everybody agree with me, guys? Can you give me a quick yes? Okay, what is this? This is what machine learning enables us to do. Okay, machine learning, it is doing behind the scenes, algorithms perform complex mathematics, statistics, and probability. Based on that, what do? We go ahead and make some business decisions. But the question here is, how did we come up with this line? Is the question. So now let's try to dig a little bit deep and try to understand that, guys. Take a look at this. Back to salary and experience. Salary is the dependent variable, generally represented on the y-axis. Experience is the independent variable. What do? The first step is plot the points. You take any company, you take their data, plot it. We should be able to plot the points as x and y axis, guys. Now what we do, we'll just go ahead and draw a random line. Okay, imagine we start with random line. Imagine this is Rajesh. Rajesh is drawing a random line. And now what he's doing is, the second step, what he's going to do is on the line, once he draws line, he's going to go to each point and he's going to project onto the line, onto the black line. Wherever the red point is meeting the black line, okay, what is that? That is the green point. Okay, so it is meeting the black, this one here, it is meeting here. And if the one which are below here, if you project them here, it's meeting there. So all those are green points. So now what these points are suggesting is, let's take this guy. This guy, let's say, his actual experience is, let's say, 7 years experience. And what is happening? Let's say this is coming to be $100,000. What is this? This is his actual salary is $100,000. Wherever this point is meeting, when you project this, wherever the line is meeting the black line, if you project this one, what is this? Let's say this is coming to be $70,000. So what is the difference? This difference is 30,000. So what is this green point suggesting? Or in other words, we can translate this and say, the line is suggesting, this line is suggesting for somebody with 7 years experience, you should be paying $70,000, but it looks like you're paying $100,000. To understand that, imagine there's a cricket match tomorrow. Rajesh is a big fan of cricket. Rajesh is predicting Sachin is going to score, let's say, 100 runs. And what happened? Imagine Sachin scored 70 runs. Okay, so the difference between 100 and 70 is 30. What is that? That we say is the error in prediction of Rajesh. Rajesh predicted he would score 100 runs, but he only scored 70 runs. What is that? That is called an error. Everybody with me, guys. Quick guess, please. Okay, so now if you apply the same concept here, our line is suggesting that we should be paying $70,000, which is here. But what is happening? His actual salary is 100,000. Oops, one more time. Let's choose this one. Let's choose this one. His actual salary is 100,000. So in other words, let's do a little bit of cleanup. So here is his actual salary, which is $100,000. And this is per the line. The story of the line is you should be paying him 70,000. In other words, the difference. This difference is what is called the error. Now what do? That is for one point. Repeat it for this point, repeat it for this point, repeat it for this point, repeat it for all the points. What do we call? You take all the errors, you square them. You're calculating this error. This error can be calculated as a distance or just a plain subtraction of the y values. And then you square it so that some of these negative values will become positive. Because these are under the line, the result will be negative, so they will become positive. So let's say then what do? Then what you're doing is you're summing them up. Oops. Let's say come here. You are calculating, you're calling this as the error, and then you're squaring it, and then you're summing up all the errors. That is called sum of squares of residuals or sum of squares of errors. Okay, so let's say come here. Put this here. Put this here. Okay, so let's say this is E1 squared. This is E2 squared, E3 squared, E4 squared. What is it? You take all those squares and you sum them up. That is called sum of squares of errors or residual. Residual means it's a difference between the actual data point and the projected or the predicted data point, which is this one. Okay, everybody with me on this? Can you give me a quick yes? Okay, now what shall we do? We'll go one step ahead. For the sake of discipline, we're going to follow another step here manually. What is it? Now what we're going to do is, we will take y, which is our dependent variable, we'll calculate the average of y. Then what you do, you draw a line at the average of y. Now what do you do? Repeat the same process. Project all the points onto the line, wherever they meet. Okay, what do? You calculate the distance. So what will happen? This is like, now we'll call this as the distance. Then you square it and repeat that for everything and you sum it. That is called total sum of squares. In other words, imagine that's like a formula that we are using in this in solving this equation. So the first one is called sum of squares of residuals or errors, and this one is called total sum of squares. Then what do? Then we use a formula called r square equals to 1 minus SSR by SST. What this will tell is, imagine we are drawing, let's say we have drawn this line. Imagine we have also drawn a pink line here. Imagine we have also drawn a blue line here. Among all the lines, among the three lines, if you notice closely, it is the green line which is most closest to all the points than the pink line and the blue line. Everybody agree with me? It is a green line which seems to be most. So what is that? That is what r square will tell. If we calculate r square using this formula, it will give you a value between 0 and 1. Okay, the line which has the highest r square is best line. That is called the best fit line. In other words, here is a friendly way of remembering. Imagine you're searching for, there's a girl, we are looking for a good boy, a groom. What are all the points? The points are the characteristics of a girl. Matchmaking websites and things like that. What are these? You can take the characteristics of a girl and we can convert them into data points like that. Now what we are doing is, think of each line as a groom. This is, let's say, Shah Rukh Khan, this is Salman Khan, and let's say this is Nagarjuna, and let's put this as Venkatesh, or I don't know, maybe Mahesh Babu, guys. How about that? Among all these lines, what do? We want to choose the line which is most closest to the characteristics of the girl. What is that? That would be the green one. Let's give it Mahesh Babu. We'll call that as Mahesh Babu. What is that? How do you calculate Mahesh Babu? We use this formula. R square, the greater the R square, the more closest it is to all the points. So in a friendly way, we can say that is the best match, that is the best fit. In the world of machine learning, Python machine learning, you'll keep hearing the term called best fit. What is it? The green line is the best fit. What is it? The story which is coming out of it is indicating you pay $30,000 for a fresher, and it is now also capable of telling us if somebody is going from 3 years to 4 years, how much salary we should pay, versus if somebody is going from 4 years to 5 years, for how much salary we should pay. It is capable of telling us. So what are we doing? Indirectly, we are taking the mathematical steps, and now we are making some business decisions. Everybody with me, guys? Quick yes, please. Okay, so what is this? This is machine learning. This is called linear regression. Imagine, back to Rajesh, you ask Rajesh, you give him a paper and a pen, and you ask him to plot all these points on a paper, then go ahead and draw a line, a blue line, a green line, and let's say we'll draw another line here, we'll draw another line here, we'll draw another line here, another line, 10 lines, 20 lines, or maybe 100 lines. Can any one of you take a guess what would be the problem Rajesh would have in doing something like that, guys? He will sit and cry. In other words, you might be paying him a lot of money, but he'll still sit and cry, because that's a lot of manual work, that's a lot of unproductive work, calculating the distances like that on a piece of paper and things like that. What do? That's where you bring in the machine. What will the machine do? The machine will draw lines. What is that? That is the algorithm linear regression. What is it? It is doing the complex mathematics, statistics, and probability. What do? To drive a car, what do? You turn the key. happening inside the car? The petrol is getting converted to electricity. So what is the petrol getting converted to electricity? It is a complex mathematics the algorithm performs. What do? You call the algorithm. It is not necessary for us to create or design an algorithm. If it is necessary, we can do some research. Generally, are done at a PhD level and things like that. As data scientist, it is not necessary for you to design or create an algorithm, but you should know when to use what kind of algorithm and things like that. Everybody with me, guys? Quick yes, please. Cool. Okay, so that is the story of the linear regression, and let's see where we are. Okay, so now let's jump into a little bit of example and try to understand what we have here, guys. We'll take an example. So back to our data. Okay, so here is today for I'll start with a simple example. Okay, bring this up back to, let's say, the Jupyter notebook. So I think it is here, and we'll say new notebook. Okay, remember Jupyter notebook is a web IDE, guys. Okay, we'll start with first step is importing the three packages. NumPy is a package for arrays and matrices. Pandas is a package for data frames. We have briefly looked at NumPy and Pandas, guys. These are seas and oceans themselves. In other words, there are hundreds of functions available which in NumPy and Pandas. We cannot look at everything, so we looked at some of the important stuff. Matplotlib, if time permits, we'll again try to have a look at this one, but it is a package for visualization. We're going to import these three packages, guys. That is the first step. Now we're going to import a data from here. This is a path on. This is the path of a file on the Google Drive. What we'll do, we'll go ahead and say read CSV. When you say read CSV, what will happen is the file is being read and the data frame is getting created. So here is DF. Take a look at this. What is this? This is a simple data set where we have how many hours a student has studied and what is the marks they scored. So let's say, for the sake of simplicity, here is first student. He's studying on an average 6.8 hours maybe every week. He's scoring about 78.5. Then here is another student who's studying 6.5 hours. He's scoring about 76.7. If you scroll all the way down, 200 students are there, and we have their hours and how many marks they're getting. Okay, now what can we do? Let's try to understand what we can do, guys. Okay, so what did we do? We have just created a data frame. If you recall, df.head will give you the top 5. This is the top 5. NA means it's missing value. It's like a null value. It's a missing value. It's corrupted data is what you can think of it, guys. Okay, so there is some bad data in this file. Then you have df.tail. If you recall, it's telling you the tail gives you the last 5 rows. The head and the tail, this is the initial inspection of the data. Okay, you're just getting a feel of the data. Then here's a slightly tough one, df.info. This will give you the metadata. It's telling you, hey, there are 200 rows, 0 to 199. It's a zero-based index. There are 2 columns, study hours and student marks is what we have. Now notice here, study hours is 195. Student marks is 200. So what is study hours is 195? Means out of 200 students, only 195 students study hours are there. 5 of the students study hours are not there. So what is that? That is called missing data. So in other words, we do have some missing data. Both of them, they are taken as floats. Float is nothing but decimal values. So what is it? Info gives you the metadata. Okay, everybody with me, guys? Can you give me a quick yes? Yes, I'll be sharing the code and things like that, guys. Don't worry about that. So now what we'll do, we'll go ahead and go to the next step, which is look at the basic statistics or descriptive statistics by using describe. Take a look at this. Here is describe, and what is describe telling us is, put this here. Take a look at this. Let's take study hours. The minimum is 5. Among the 200 students, there are some students who study only 5 hours. There are some students who study up to close to 9 hours. On an average, it looks like our students are studying about 7 hours a week. Okay, or maybe that's 7 hours a day. 7 hours a day is too much. But and here is the variance or the standard deviation. If you recall, this is the first quartile, second quartile, and third quartile. Okay, these are this one is the median. In other words, we are just getting a feel of how many hours students are studying. Why some students are studying only 5 hours? Why some are studying their maximum up to 9 hours? That's a good one. The more they study, and on an average, students are studying 7 hours. What is this? This is called statistical thinking, guys. This is what we do as data scientists or AI professionals. Then come take a look at the marks. It looks like the minimum students' marks is 68.5. The maximum is 86. On an average, students are scoring maybe 77.9, which is 78 marks. Not bad. Maybe this is English, maybe this is mathematics, or maybe this is physics, or whatever it is. But we are getting a feel of the data. We're trying to understand the basic statistics. This is what is called the descriptive statistics. Everybody with me, guys? Quick yes, please. Okay. Then let's come back here. Take a look at this, TF tail. Shape. Another one is shape. So for the sake of discipline, I'll also run this one. Say, put this here. So TF dot shape. Shape will tell you how many rows and columns. There are 200 rows and 2 columns. As simple as that, guys. That's what shape does. Then move to the next one. Here is, now take a look at this one. I know we have not dealt a lot with matplotlib, but take a look at this, guys. What is happening is, on x-axis we are putting the hours, on y-axis we are putting the student marks, and our visualization looks like this. So come here, put this here, put this here. So now what this is telling us, if you notice, the data seems to be flowing in this direction, which means we can roughly say, as the x-axis values are more, the y-axis values are also more. In other words, as the study hours is increasing, the marks is also increasing. Okay, for these are the group of points where study hours is more, x-axis is more, and y-axis more. But take a look at these. What is this? Their study x-axis value is low, and their y-axis value is also low. Okay, so it looks like when students are studying more hours, their marks are more. When students are studying less hours, their marks are less. Can you think of reason why it depends on, why the marks depend on study hours, guys? Can you think of reason? Why do students' marks depend on the study hours? More practice. Good answer. Short and sweet, it's practice. The more you study, the more you're practicing and things like that, the more you're understanding, the more the knowledge. Good answers. As simple as that, guys. Nothing rocket science there, nothing great. So in other words, what is this? This is called positive correlation. There seems to be a positive correlation between study hours and student marks is what we can say. So what is this? Visualization. A visualization tells you whether it is positive, negative, or neutral. Here it is telling correlation. But remember the mantra, correlation does not mean causation. What is causation, guys? Causation, the mantra of causation is impact. Smoking causes lung cancer. It's an impact that you'll have. But can we say, if you study, definitely you'll get more marks, guys? Can you say that? If you study more, you'll definitely get more marks. Do all the students who study more get more marks? Okay. Well, okay. How about not necessary? Okay. How about the majority of them, guys? Imagine there are 100 students. Majority of the students, if they study more, will they get more marks or not, guys? Maybe there are few of them. Logically, you can say there are few of them. Maybe they don't get more marks even if they study. Maybe they're not concentrating. But majority of the times when they are, okay, some of you are saying 50-50 chances and things like this. So if you want to understand that, what do you do? That's where linear regression comes to rescue. So let's try to understand, guys. Okay, let's see what we can do. Remember, visualizations give you correlation, but they don't tell you the causation. So before that, what we'll do, take a look at this. Here's a little bit of data cleaning. What we call as data cleaning. What is it? Take a look at this. df.isNull means you're checking. df in this data frame in the columns, are there any null values? So there are 5 null values here. There are 0 null values here, is what it is, guys. Okay, so we do have some missing data. 5 of the students we did not record. Now here is df mean. If you say df mean, it is going to each column and calculating the average. The average studies hours is 6.99, that is close to 7. The average student marks is 77.9, that is close to 78. So in what way is that useful? We'll do something. Take a look at this. df2 equals to df.fill_na df mean. Okay, so we'll execute this one. What this is doing is now say df2 dot is null dot sum. If you do this, now notice study hours, there are no null values. There are no null values in earlier we got 5 null values. 5 of the study hours of the students are missing. Now what did we do? We filled NA. NA means null values. Fill NA with mean. What is it? You can use mean, you can use median. Generally mean and median are used. Mean or median are used. And what's happening? Well, that value is being filled up. In other words, if you have any missing values, one of the techniques that we use is you can take the average of the mean and fill up the null values with that one. This is called improving the quality of the data. Everybody with me, guys? Quick yes, please. Can you drop an A? Yes, you can also drop an A. There are many other scenarios you can use linear regression itself to do. Those are advanced, but for now, we'll try to follow this technique, guys. So now what we'll do? Take a look at this. df2 is null sum. We verified that, and verified df2 dot head. Okay. So earlier, I think this value was null value, NaN. So now we've filled it up with a mean or an average. Then what we are going to do is, let's come back to df2. So here is, let's say df2. Let's run it. So here is the student hours and the marks, and let's come here. Now we're going to follow a certain process. We'll try to understand how to follow this process. So choose this one. So here is our data frame. This is a complete data frame. Imagine that is 200 rows and 2 columns there. Now what we are going to do is X. What we are doing is, we'll say here is X. Let's run this one. We're doing a df2 to drop. In other words, when you drop it, what is happening? When you drop the marks, drop means remove the student marks. So visualize as if this is, let's say we'll choose this one. Here is study hours. We'll put it like this. This is the study hours, and here is the student marks. Okay, we're going to take the study hours. We're going to call this as X. For sake of discipline, we'll call this as X. So let's say choose this one. Put this here. We'll just go and say this is X. What is X? X is only study hours. And then here is student marks. Say this is student marks. We're also going to separate this. We will call this as a Y. The notation is X and a Y. In a machine learning world, you can also give other names, but generally that is a common standard, guys. Okay, so what is X, guys? How many marks you will get will depend on student hours. Do you think how many hours students will study will depend on their marks, guys? How many of you agree? Will the study of the hours of a student depend on the marks? So let's say take Pujita. If she is getting very high marks, will her study hours vary, guys? It's hard to say. It's not very straightforward. Again, we'll need to give a little bit of thinking and things like that. So let's say, give me one moment. Okay, so here what is happening is student marks is dependent on study hours. More than study hours is dependent on student. Everybody agree with me? How much your marks you will get will depend on the hours you study, rather than vice versa. So what do we say? Y is the dependent variable. Y is the dependent variable. X is the independent variable, is what we will say. So even when we are saying X, that is called the independent variable. In the world of machine learning, what are we doing? We separate the dependent and the independent variables. That is the first step. Then come here. Here is Y. So say here is y. If you take a look at this one, drop is removing the, and that is the student marks. Is acting like a single data frame with a single column. Okay. Now what is it? Print the shape of them. Both of them should have 200 rows in one column. So that is the independent variables, 200 rows, one column. For sake of simplicity, this is 200 rows and one column for the sake of simplicity. Okay, next what we do, okay, so come back here. Now we separated x and y. Remember the blue box is independent variables, the green is the dependent variable. Now what we are going to do is, we're going to call a function called train test split. sklearn is a package for machine learning. Okay, we're going to import a function called train test split. So let's say, come here. Here's a sklearn. Give it a moment while that is running. Yeah. And we're going to run a slightly complex function. Here is train test split. This is the name of the function. What are we doing? We are going ahead and giving the independent variable and the dependent variable. We're saying test size is 0.2. Random state, we'll talk about random state in the coming up days, but we have given our independent and dependent variable to this one. What this function is doing is it has given object 1, object 2, object 3, object 4. It has given 4 objects. From 1 or 2 objects, you're getting 4 objects. This process is called unpacking. We briefly talked about unpacking, tuple unpacking and things like that, guys. Okay, so let's try to understand that. What is happening is, now imagine, for the sake of simplicity, let's say choose this one. Let's say, come here, let's choose one of our guys. Let's take back to Purna. Let's take Purna, and what we'll do, we'll imagine, for the sake of simplicity, this is Purna. And what we are doing is, we'll take this one. We have let's say we have given x, and y, which is the hours and the student marks, to Purna, and Purna is looking at it. Now let's say, okay, start here. What we will do is, we will take this x, which is, let's say there are totally 100 students here, but let's divide that into 80%. These are 80% of the hours. Then we will take study hours, and then we are taking this one. This is 80% of the marks. Okay, in other words, let me go ahead and clean this up. This back. This is how it is. What we are doing right now is, indirectly, back here, take this one. We are taking 80% of the students here, whatever that number is, and then we are taking their hours, and then we are taking how many marks they got. This is 80% of the marks. What we are going to be doing is, let's choose this one, and here is okay, here is our algorithm. We are going to choose this, the hours and the marks to our algorithm. Okay, now what will the algorithm do? It is going to take this data and it is going to perform the linear regression. Just like we have done the salary and the experience, it's going to plot the points. It's going to draw a lot of lines. It will figure out the best line. The best line is, let's say, this line. Oops, one more time. It's not allowing me to select it. Okay. Let's say here is the best line for the sake of simplicity. Here is the best line. For sake of simplicity, the yellow line. It is going to, the algorithm is going to do the mathematics of all this thing, and let's say, what will it do? It will give you an output. That output is called the model. The algorithm is giving you the model. For that, what did we do? We have, out of 100% of the data, we have separated 80%. 80% of the data and give it to the algorithm. The algorithm is giving you some output, which is the model, is what it is, guys. Okay. So let's say, if there's more simple way of saying it. Okay. How about this, guys? Let's do a little bit of backup. From here, back to Purna. Start with Purna. Here is Purna. Purna is a tutor. He's a tuition master. Let's take Rajesh. Let's say let's choose this one. Here is Rajesh. Rajesh is a student. Okay, so think of Purna is tutoring Rajesh. Purna has questions and answers. For the sake of simplicity, we'll call them as questions. These are questions. These are answers. Now, what are they? Let's say we had 100 questions and answers. The first step that Purna, the tutor, has done is he has separated the questions and answers. Okay, he has separated the questions and answers is the first step. Here are the questions, here are the answers. Now he's calling Rajesh. He calls Rajesh and he's about to give him the questions and answers to study him. But he gets an idea. Okay, what is that idea? What he does is, let's say there are 100 questions and answers. What he's doing is he's taking only 80% of the questions, which is the pink box. That is 80% of the questions, 80% of the answers. And what is he going to do? He's going to give it to Rajesh. What is Rajesh going to do? Rajesh will study them. As he is understanding the concepts, in his brain, what he's doing is he's painting a paint in his brain. If he understands the concepts well, he will be able to perform the exam. Okay? So let's say Rajesh studied the 80 questions and answers, and he says he goes back to his tutor. Purna says, buddy, I'm ready. Sir, I'm ready, and things like that. So now, what Purna is going to do is, he has purposefully hidden roughly about 20% of the questions here. He could have given all the 100 questions, but he has purposefully hidden 20% of the questions. What is Purna going to do? Purna is going to take this 20% of the questions and is going to give it to Rajesh. And what will Rajesh do? Imagine Rajesh is going to come up with his own. He's answering these questions and is coming up with his own set of answers. Okay, these are his own set of answers, but here are the actual answers. This box is the actual answers. What is this one? After Purna answers, we will put them side by side and see how many of them he answered correctly. How many of them he answered correctly versus how many of them he did not answer correctly. What is this? This is the process of splitting or partitioning. In other words, the 80% of the questions, this is the 80% of the questions is referred as X, which is questions underscore train. This is called train. Okay, then let's take the green box here. This is called Y underscore train. Y underscore train. So let's say, do a little bit of cleanup here, just to keep that a little bit visible. So here is important thing. That's where he's forming a paint in his brain. In his brain, when he studies the questions and answers. So now, let's say, come back here. Choose this one. Put this here. Put this here. We have given, let's say, this is the, this one. This is the 20% of the questions. This is the 20% of the answers. But when we have given a test to our guy, Rajesh, these are the answers he answered. And later we will compare them. So the pink box here, which is 80% of the questions, choose this, come here. This, we are calling it as X underscore train. This is questions which were trained. And this green box here, which is 80% of the answers, we're going to call that as Y underscore train. Okay, so what is this? These are the two things, questions and answers. Our student Rajesh studied and he formed a picture. What is this? This is at a neurological level. Who is Rajesh? Rajesh is the algorithm. What is the paint he's painting in his brain? That is what we call as a model at a mathematical level. Now what are we doing? If you take this yellow box, this, let's say come here, is it 20% of the questions. We call this as X underscore test. This questions underscore test. And the orange box, let's say come here, move this a little bit here, and we will call this one as y underscore test. Y underscore test is, we did not give him the answers. We are just testing. X underscore test is given to our student Rajesh. Is going to internally use his understanding of the concept and is going to answer. Once he answers, we are going to compare with this one. Everybody catching it, guys? Everybody with me? Can you give me a quick yes? Okay, roughly, what is this? This step is called partitioning. Almost most of the algorithms which are supervised learning, which will again talk in the coming up days, are going to follow this process. So I'm probably going to explain this one more time in the coming up days, multiple times in the coming up days. But just try to keep that picture in the mind that this is what is happening, guys. So here, slightly from a computer science standpoint, what do we call one function? When you give one or two objects, okay, it's taking one or two objects. What is it doing? It's giving you more than one object. This is called unpacking. So now there are 200 rows, if you say what is a shape, we are roughly dividing that into 80% and 20%. Come here. Notice what happens. 80% of 200 is 160 questions, 160 answers. We are giving it to our student Rajesh. He's studying. After he studies, we're going to give him X underscore test. This is the questions. 40 questions we'll give him, and we'll see how he'll answer. How many of them he'll correctly answer and things like that. And then we'll compare his answers to the actual answers. Y underscore test is called actual answers. Everybody with me? One more time. Quick yes, please. So this step is called splitting or partitioning. This is called supervised learning, guys. Next, come here. Now, time to get into action. So what is happening? So now, this is the stage where the tutor was Purna. Purna has come. He's separated the questions and answers. Then he split his questions and answers into 80% and 20%. Now he's going to call. What is our student's name? Rajesh. So what is it? Linear regression is the algorithm. We are going to import it. As we're creating an object here. So a little bit of object-oriented terminology. And then what do we do? When you say fit is where the mathematics, statistics, and probability is happening. Give him 80% of the questions and 80% of the answers. When you do fit, this is where he's painting a painting in his brain. This is where he's studying, he's understanding all the questions and things like that. Now take a look at this. Once you fit it, this is where he studied. And take a look at something called coefficients. What is this coefficients? It's coming as 3.9. What this coefficient is telling is, it is indicating for every 1 hour that our students are studying, their marks is increasing by 3.9. 3.9, which is roughly 4% or 4%. For every 1 unit of study hours that they are involving, for every 1 unit of study hours, their marks are increasing by 4 marks is roughly what we can translate it into. In other words, imagine, let's say, come back to Rajesh. Rajesh is, let's say, studying 6.8 hours. He's studying 6.8 hours and is scoring 78. But let's say his parents come and tell, hey, can you get they hired this tutor, Purna, and they're telling, hey, we want our kid or our child to get into 80%. We want him to be above 80, not below 80. So now, imagine we tell him, hey, come back here. We tell him for every 1 hour you increase. Let's say you increase it by 1 hour. Let's say 6.8 to 7.8 units on an average. If you study, what will happen? Roughly, you will be in the 80s. Okay, what is that? That is the interpretation. What is happening? That's an impact. What is that? That's the magnitude. That's called the magnitude. That is called the causation. Everybody catching it, guys? Can you give me a quick yes, please? What is it? Regression. With regression, we are not only able to understand the correlation, but we are also able to interpret a causation. What is causation? Smoking causes lung cancer is a logical causation. Logically, that is what is happening. But what is this one? This is a statistical causation, a mathematical causation. It is indicating an impact like that. That is called a mathematical or a statistical causation, guys. So every student, now imagine you go to a school, you tell all the teachers and all the students, guys, you study for every 1 hour you study more. Your marks are going to be increasing by 4. 4 marks is what you tell all the principals and the teachers. In what way would that help, guys? In what way is that helpful to the teachers and the principal? Can you think? Can you give a reason, or can you think in a friendly way? You go to a school, you go back to your school now. You're a data scientist, you went back to your school, you're talking to your, you don't talk to students, but you tell the teachers and the principal. You tell them, hey, I took your data, I did some analysis, I'm observing, for every 1 hour they increase, their marks are increasing by 4 marks. In what way would that help would that be helpful for your teachers and principal and the school guys? It will improve. And teachers, what will happen to them? That is insightful. That is something interesting. That is something useful. That is something helpful. But let's say you also go and share it with the parents. You also go and share it with the children. What will happen? Well, they might get inspired. Hey, they will somehow, they did some, some advanced stuff, some sophisticated, or somehow they're coming back and giving us this kind of thing. So let's take Pawan. Pawan is studying only 4 hours, 5 hours. What will he do? He will put 1 hour more, and he will test himself. Okay, I'm going to study 1 hour more every day, and let's see if this really happens. What is it? You're kind of giving a reason for them to get inspired. Okay, our objective is not just to share the knowledge, but to actually use it, to actually get inspired with the data. What do? You take, you take this kind of a concept, you apply in healthcare, you apply in telecom, you apply in every business. That is what every business is trying to understand. This is what every business is trying to understand. And what do they need? This is what they need, the data scientists and the AI professionals. Everybody with me? Quick yes, please. Cool. So that is coefficients. That is the story of the coefficient. What is the story? This is the story of the data. The story of the data is, it is telling every 1 hour you increase, your marks will increase by 4 units, 4 marks, roughly. Then come here, roughly, from a discipline standpoint here, intercept may not be very, very insightful, but this is where the y-axis is meeting. The best fit line is meeting the y-axis, so roughly 50 is what it is. It is not really very interpretable, guys, but later we'll see. But now let's come back to Pawan. Let's say Pawan is studying only 4 hours. 4 hours, and what we'll do, we want to see how much marks he'll get. He will get 66 marks. Next, let's say, let's come back here. Who else we have? Here is Hari. Hari comes back and says, hey, I'm studying 5 hours. How much will I get? Okay, let's say I'm studying 5 hours. He'll enter 5. Our model is suggesting he's going to get 70. What can every student do? They can just put their numbers. We can give them an application. They can put their own numbers. They can play around. They can kind of get a feel of it. They can get inspired. Oh, it looks like Pawan is getting 66 with 4 hours, and if I study 5 hours, I'll get 70. I can beat Pawan. In a positive way, in a constructive way, not in a destructive way. Everybody catching the point, guys. You're kind of trying to inspire the students and trying to be a little bit more, guys. So remember, F equals to ma, back to school, force equal to mass multiplied by acceleration. But what we need to do, this is our E is equal to mc square. Your task, what you will be doing in real world is, they will select you as a data scientist and they will give you the data and say, hey, can you put this kind of concept in my own data, in our business data? That could be healthcare, that could be telecom. And remember, you will not be alone. You will have a team of people. It is not a one-man army. It is going to be a team of people who will sit. But what will happen? Imagine Vinay is a data scientist, is sitting, he is hiring a group of data scientists. When he sits with his team, he expects his team to understand this terminology, this kind of thinking. This is statistical thinking. This is a scientific or a mathematical thinking. This is what the businesses are looking for, guys. So let's see. Let's go ahead. Now take a look at this, guys. Let's come back for the sake of discipline. LR is our student Rajesh. And when you say predict, what is happening is he's going to test. What are we doing? Here we gave 4 hours. We tested how much we got. Now we are giving X underscore test. X underscore test, if you come back here, is 20% of the questions. Okay, 20%. So what we'll do? So here is Y underscore pred. So if we give him this 20% of the questions, so these are the answers he's coming up with. These are the hours that he's predicting. So what do? Let's say, come here. We'll build a data frame. X underscore test is the 20% of the data. Y underscore test is the actual, and here is the predicted. Study hours, student marks. We're building a data frame. Data frame. So let's say, copy this and run this. Notice, Study hours is our independent variable. So originally, a guy who studied 8.3 hours, a guy who studied 8.3 hours scored 82 marks. A guy who studied 7.2 hours, he scored 77.5 marks. But what is our model doing? Notice, a guy who studied 82 marks, our model predicted as 83. A guy who studied 77 marks, our model predicted as 78. Okay, so what is it? These are pretty close. Let's say this was 38 for a moment. That is too far away. That's too much in error. Everybody catching that, guys? Can you give me a quick guess? If our prediction is close, then the error is less. But if our prediction is too high, then that is not a good model. Okay, now what do we have? We have about 20 or 40 students. We cannot look at everything manually. What do we do? That's where we will use. Come here. We'll use a score. Score will tell you the R square value roughly. So here. So 0.95. That is how much we are able to explain. 95% is what we are able to account for. So let's take a look at another one. Here is scatter plot of the questions and answers. This is study, this is the marks, this is the hours, positive correlation. What we'll do, we'll plot the predicted values here. Let's see what this does. Here's the best fit line. Red line is the best fit line. This is the best bridegroom for all these characteristics of a girl. Is a friendly way of understanding, guys. Okay, so now what we'll do, ideally, imagine you're working as a data scientist in real world. You will, what is this one? Our LR is our model object. That is a model we built from the data. What do we do? You will save it to a file. What do you do? Joblib is a package. You say dump. This is how you save it to a file. And now that file, let's say there's another Python UI team, somebody working in a Django or maybe some other Python UI or maybe Java or .NET UI. What will they do? They can say load and the model. Okay, once they load, what is this? Here is a student is studying, let's say 6 hours. What will they do? They'll pass in the 6 and we're predicting about 74 marks. Okay? So what is this? This is how you can kind of, so this is a simple deployment. A very layman's deployment, or very simply, you save the model object to a file and then give it to them. They will do a load. When they load it, the object is created, the model is created, and they'll call the predict method. That is the method in the procedure. Everybody catching it, guys? Quick guess, please. Accuracy here is nothing but R square. The higher the R square, 95%. So we got 0.95 means we are not able to explain 5%. We are not able to explain. So 5% is roughly the error. We can also manually calculate the errors. That we'll see for another session. Okay, guys. So another thing to also keep in mind, guys, if you go back up here, this is our data. We have close to 200 rows. Let's say scroll up here, not this one. Scroll up here. Here is student marks. Here we go. Study hours and student marks. Imagine you give this kind of a data to a teacher. You tell him, hey, somebody who's studying 6.8 hours got 78.5, and they're studying this much, they got 76 point, and you give 200 students like this. You ask a teacher to look at this kind of data, and then you tell him, here is come Rajesh, he's studying only 5 hours. Can you tell me how many marks he'll get? It will be a very, very it's a very meaningless task. It's a very complex task, and it's not easy, guys. Okay, so what do? Bring in the machines. That is what is machine learning about. This kind of task cannot be done by humans. When humans fail, bring in the machines. What do machines do? Machines do the complex mathematics, statistics, and probability. What do? You learn. This is machine learning. Everybody with me, guys? Quick yes, please. Good. So that is the first touch of our first machine learning algorithm, guys. Tomorrow, I will try to give you another example of a slightly more sophisticated one, and we'll see if we can dig. I have 2 or 3 things I'm working on. I'll see what I can come up with and things like that, guys. Okay. The coding, it will take a little bit of time, just one. I don't expect you to become perfect, but you try to practice it. We'll try to go over a few more examples like this and give it a little bit of time. and you will be able to understand. This is not sentimental analysis, guys. Sentimental analysis is based on textual data, but this is numerical data. How to compare column 1 is less than column 2? Okay, Hemant, it is possible. Short answer is possible. You can use a filter, buddy. That is a short answer. Which model is okay? That's Pradeep. That what you're asking is slightly advanced. We build multiple models and we try to decide which is the best model. If time permits, I will try to go over that concept in the coming up days, buddy. Load a file in Jupyter. If you're loading a data file, you can use read CSV. If you are loading a data file, a JSON file and things like that, you have functions called read CSV in pandas. This is how you can load a file and create a data frame. Somebody was asking, guys. Suggest to send the material email ID. Oh, I think yesterday, Mohan, we have shared it, but I'm sure we can do that. We can also use SVM, yes. Okay. So based on the next 2 weeks, whatever I can cover, I'll try to cover, guys. And we'll look at different other examples also. Pardon me. Okay, sorry about that. So explain, okay, don't be in a hurry. We'll look at a few more examples and you'll understand what is a model. It becomes more easy for me to show you the data and understand, guys. We'll go over this kind of examples more from now on, and that will give you a bit more understanding. There you go, guys. Jagannath, thank you, buddy. That is where you can download the code until the last week, guys. This week's I will upload it maybe by the end of this week. Syllabus at a high level, it is more about machine learning. If time permits, I'll also touch a little bit of deep learning, Anil. Performance. These are all advanced concepts. I'm still not yet there to talk about the performance, multiple models, and things like that. We are slowly going there. Okay. We're still in the first algorithm. Those are slightly, you need a few more algorithms to understand the performance techniques and things like that. Okay. Okay, guys. Okay, the feedback link, okay. Suitable algorithms, yes. Coming up days, guys. It's too short of time for me to share that much of information. Those are some pretty detailed concepts. Skill set to become data scientist. Python is the king. Python, machine learning in Python, deep learning in Python. This is the king. Leave everything else. Forget about everything. If you know that one, if you have that on your resume, that will be what people will be looking for, guys. From the data, we build a model. We give the data to the algorithm, and the algorithm becomes a model. And the model we are using for making a prediction. Okay. Ooh, network programming. That's a different topic, buddy. Dask and pandas. Dask is, I think, faster pandas. It makes the pandas run faster. Optimization methods will be slightly out of scope for this course, guys. Yeah, we'll look at the other various algorithms in the coming up days. So, who's that? Rakesh. Bhuvana, are you trying to load a data file or are you just trying to load a Python file? Or a Python notebook? Data file, as I said, what kind of data file? Is it a CSV or is it a... Pandas, matplotlib are packages, that is true. Okay. Yes, it is possible to automate, guys. Python is very friendly. Variance and bias. It's too early to talk about those variance and bias, guys. Those are slightly advanced topics. We'll be talking in the coming up days. Okay, so gentlemen, ladies, for today, I will stop it here and let's continue the journey for tomorrow, guys. Logistic regression also will be talking in the coming up days. Okay. With that, I'll be signing off, guys. You please try to fill up the feedback form. Thank you again for joining today. You guys all stay safe. Thank you for the comments and things like that. And you guys stay safe and keep learning. Okay, guys. Thank you and bye for now, guys. Thank you again.
మాట్లాడలేదు